Hello everybody! We are in front of Technical School for Mechanical Engineering and Mechatronics Split, which has the longest technical education around this area. There are two professions that students attend here. Those are Mechanical Computer Technician and Technician for Mechatronics. There are 373 students that are attending this school and 49 employees. In 2018, we received the award for the most beautiful garden, the Green Charter for the Environmental Protection and Energy Efficiency. Well, it's working. So here you can see the Steora Smart Bench produced by one of our former students. His name is Ivan Mrvoš. He's the owner of the company Include, as you can see. The school has long and interesting history. The building was designed by an unknown architect and built in 1940. In the Vienna secession style during the Austro-Hungarian Authority, it was actually built. Then there was a need for an agricultural school. The building was surrounded as well by the vineyards. In the school, we have Center for New Technologies. Students over there have subjects from robotics, CAD and CAM design, pneumatics, hydraulics, sensorics, and so on. We also have a corner for energy efficiency and environmental protection. Since 1920, technical subjects have been introduced in this building. In 1969, Technical School Center was established, and in 1992, 4 schools, including Technical School Split, emerged from the center. In 2010, the school changed its name to Technical School for Mechanical Engineering and Mechatronics. Also, many former students or teachers of this school were or still are famous writers, architects, musicians, such as Dinko Šimunović, Emanuel Vidović, or Josip Hatze. Now we will show you what our students are learning through different subjects.
The objective of the subject is to acquire basic practical knowledge of electrical machines and devices. We will be doing an idle test and a short circuit of the transformer in this lesson. With these experiments, we obtain the main characteristics of transformer experimentally.
We connect 3 basic instruments, ammeter, voltmeter, and wattmeter, and measure current, voltage, and power with them. In this way, we acquire competence that are essential for working in the profession and increase self-confidence and safety in working with instruments and electrical machines.
So now we're doing the idle test of the transformator. First, we'll be connecting from the output of the slide regulator. Then we're connecting the ammeter. And the current branch of the wattmeter. Now we'll connect the voltmeters. And then the voltage branch of the wattmeter. That 99 volts. $130 volts. $160. 190 volts. And 222 volts.
So the name of this subject is called Designing Products with the Aid of Computers. And we are working in CATIA, which is one of the best programs for 3D designing, and it's made of multiple subprograms. We are going to be working in mechanical design, and there are also shape, which is for more complicated surfaces, and drafting for 2D technical drawings. So we have already opened a new part, and now I just select a plane to go into Sketcher, and now I can make a 2D sketch which I can make into 3D, but I already have a pre-made example. So this is a shaft of a gearbox, and this is a gear. So they are placed right here. And this is the shaft, and this is the gear. So we need to make a metric thread in this shaft. So we go into Sketcher, and I can place a point anywhere. So we use constraint to set the distance between the point and the axis. So here and here. So according to the sketch, I need this to be 12.5, and this needs to be 0. So now we go out of Sketcher, and we unselect this, select the whole command, select the point and the plane. So now we go into extension, and we use a V bottom because that's the shape of the drill that we are using. We go back to thread definition, and we use the metric thick pitch because we have an M8 metric thread, which is a preset. So we have a whole diameter that is preset to M8. And the thread depth is 12, and the hole depth is 15, just like on the sketch. Now I just press OK. So the thread will not be shown here in the 3D design, but it will be shown in 2D drawings. So that now I have to chamfer this edge here. So I select the chamfer command, and the chamfer is 1 by 1 according to the sketch. Now I just select the edge and press OK. So that would be it for this drawing here. We will move on to the next example. So here we have the gear that we are working on, and we need to make holes in it, so we make it lighter. So we select the plane, go into Sketcher, and now I select a point, and I use the constraint to determine the distance from the axis once again. Now I accidentally placed the point exactly how it should be here, but here it's supposed to be 0. And now I need to draw a circle. I can draw it any size, and I can delete the point. And now I use constraint to see the circle diameter. So this is the diameter, and according to the drawing, it's supposed to be 30. So now we have our circle. We go back into 3D, and we use the pocket command. Now we don't need to use dimension, we just use up to next because it will go up to the next surface, no longer, no shorter. We press OK, and now we have our hole. But I need 6, so I need the circular pattern command. And I have 6 instances, and they're divided by 60 degrees. So I press OK. I need to select the first surface first. and press OK. And now I need to fillet the edge between these two surfaces. So I need to unselect the surface, select fillet, and I need to fillet it to 5 millimeters, and I need to select this edge, press OK, and that would be it.
Cilj ovih vježbi je da na temelju priloženih tehničkih crteža prođemo sve naredbe.
So the point of us doing this program is to go through all of the commands in the program, so it's easier for us to do other subjects in this curriculum in the future, or to do whatever we need to do if our job is anything similar to this.
With CATIA we also use AutoCAD. This is one of the assignments we will make in the future. This is an example of a steam engine. First task we have to do is to make a technical drawing of every part in AutoCAD. After we make a technical drawing of every part in AutoCAD, we have to make an assembly design in 2D, also in AutoCAD, and the positions of every part. After we make that in AutoCAD, we go to CATIA V5, and we have to make all the parts in 3D. This is an example of cylinder. This part was modeled based on his technical drawing we made in AutoCAD. After we modeled every part, we go to a subprogram assembly design, and we assemble them in one functional unit. This steam engine works in the way that we heat the first cylinder, and the hot air goes through the engine and expands into the second cylinder, where the air moves the piston, and here linear movement transforms to circular movement. The next task is to add a simulation that we are going to learn in the future. The main goal of this assignment is to develop student skills and creativity.
Hello, today we are going to present the subject called Control and Regulation. The subject itself is listened to by the students in their third year of education for technician for mechatronics, and it needs to teach the student the basic skills and knowledge needed to connect electric schemes. Sometimes we need to use one contact in more electric circuits, and that's where the relays come in. The relay itself, it's an electromagnetic component based of two main parts. The parts are the coil and the contacts, which can be normally open or closed, corresponding to our needs. Today our assignment is to realize the memory function using the relay technique of the RS bistable.
For the realization of the memory function, we need two push buttons, set and reset, one of which is normally open and the second is normally closed. Two outputs, in this case we have electric bulbs, and one relay with three corresponding contacts, two of which are normally open and one is normally closed. Before we go on to connect this electric scheme in real life, we will test it in this program. Now, by pushing the set button, we realize the memory function, and the first bulb lights up, and no matter how many times we press the set button, nothing changes. And to bring it back in its original position, we just need to press the reset button. Now that the scheme is working, we can go on and connect it in real life with the real equipment. The electric scheme is almost finished. Now we will finish it and test its two memory function states. Now, as we had in the program, we have two states, set and reset. By pushing this set button, we will activate the first bulb. And now, no matter how many times we press it, nothing will change. The same bulb will be on. And to bring it back in its original state, we need to press the reset button, and it's back.
And this is the classroom for CAD/CAM technologies. It is used by the students of the 3rd and 4th grade of the computer engineering technicians. We use many programs like Esprit, CATIA, Mastercam, and Cinemeric 840D. So we would make the NC code for the manufacturing on the mill and lathe machines. We also use skills we learn on other subjects a lot. It is based on a technical drawing, just like this one, which we put in the program, and we make the codes for the program. This is the final 3D simulation we have in Cinemeric 840D. Firstly, this is turning. And now we have deep hole drilling, and now we have the thread definition. So what we have here are some final work pieces that fourth graders do. We have here is a claw clutch, belt transfer, and this is a Stirling engine which we study in 3rd grade, and 3rd graders were filming how they draw it in CAD/CAM, and it works on compressing and expanding air.
CAD/CAM is a computer-aided manufacturing software program used by manufacturing professionals such as computer numerical control programmers. CAD/CAM can be applied for creating a design and project documentation, visualization tools for creating shaded images and animations, engineering analysis of geometric models, processing planning, and generic NC programming part. We will demonstrate the process of creating NC code in an example created in Mastercam program. First, we create a drawing, then we define the necessary tools for manufacturing. After that, we define the toolpath and manufacturing parameters. The whole process can be demonstrated by 3D simulations, which allows us to notice possible mistakes and correct them before generating NC code. First step is 3mm facing mill. Step 2 is contouring the shape we drew. Third step is slot milling. And the last step is drilling the 3 holes that we previously drawn. This is an example of manufacturing NC code for milling, but this time we are using the program Spirit. This is a demonstration of a simulation distinguishing different types of process: facing, contouring, and drilling. In the next example, we are going to show you the process of engraving. First, we use the create order. Then we write the text which will later be engraved. Our next step is determining the dimensions of the text. And after that, we select the plate. We have to select text, choose arrow chain command, and then we define tools which will be used for engraving the text. Before choosing a simulation, we have to define manufacturing parameters. Then we choose simulation, determine simulation parameters, and this is a simulation demonstration.
Right.
This is the school workshop, which contains a number of CNC machines, CNC mills and CNC lathes. The program we use for controlling is numeric 40D. The machines are educational, so because of that we can only work on pieces of smaller dimensions. They serve for demonstration and checking of programs that we made in CAD-CAM. On this CNC mill, we will make an engraved plate whose process of NC code manufacturing was previously demonstrated in a Sprit program. So here, take a look.
So this is the final product.
Our subject is called Renewable Sources of Energy, and we are currently studying the properties and characteristics of a solar panel collector. Since Croatia and Split specifically are very prone to sunlight, we will now demonstrate and build a solar panel collector in a program called Katia. With it, we can heat up and produce hot water, which can then be pumped to hotels, apartments, and households. Using this process, you can save up to 70% on your hot water bill.
A solar panel collector consists of housing, isolation, pipe distribution, absorber, and cover glass. Thermal energy is accumulated through absorber, the pipeline in which cold water passes and is then heated. The hot water is pumped from the tank to the user, and it's clean energy, unlike fossil fuels, so it does not pollute and we protect our planet.
This is Scorebot ER4U robotic arm. It is a system for robotic training and education. Because of its high repeatability and its speed, it is highly suited for both standalone operations and automated work cell applications. Right now, we will show you one of the basic programs that we learned at the beginning of the year. RoboCell is a simulation program for student use that works on the same principle as the Scorebot ER4U robotic arm. For making mobile robots, we use a Lego, Fisher, Arduino, and make bulk platforms, which later we program to be autonomous robots for special tasks. And they can be connected via Bluetooth or Wi-Fi.
This is an autonomous detection robot that is programmed to detect objects and push them outside the line we draw on the board. Such robots, like this one, can be used for construction, garbage disposal, and etc.
The subject we are going to do today is called pneumatics. Now we're going to do a simple assignment of certain logic functions. We already arranged some of these valves and components we're going to use today. First, we need to put a compressor, the supply units, the compressor and an air service unit. We're going to connect them each. Then we're going to have a couple of these valves. These are 3/2 valves. They are normally closed, which means when I turn the compressor on, the air won't go through because I need to push this button to let it go. I'm going to copy some of these and paste some of these valves because I haven't arranged enough of them. This is a shuttle valve which is going to allow us to allow air through when I press one of each valves. Paste one more here. Now we need to connect all of these valves to the compressor into one single group. To the air service unit. And this is a 2-pressure valve, which I'm going to show off later. Now this is a 5/2 valve. This is the main valve which controls the cylinder here. And this is a distance ruler. The distance ruler will allow us, with the combination of this roller valve, to let us know when the cylinder is actuated. Now connect. These are the entry points on this valve. And connect the exit points to the cylinder. Now I have to mark this distance ruler in order to it actually work. Now starting the simulation. As you can see, the compressed air has stopped on these valves because they are normally closed. When I press one of the valves, it will open and the cylinder will actuate. We know that the cylinder is actuated from the outside because of this ruler, and this valve is open. This little roller here, lets us know that the cylinder is open. When I press this valve, the cylinder will close. Now I'm going to show off these components, what they actually look like. This is a double-acting cylinder, which we'll show later on in real life. My colleague will connect this exact scheme but with actual components. And this is an animation how it works. This is a 5/2-way impulse valve. This first little opening is the main connection with the compressor and the air service unit. These two in the middle are 2 and 4, and these outside ones are 14 and 12. These are the valves where the compressed air gets in from these 3/2 valves, and we can see it right here on this valve. But under this, the 3 and 5 valves are here. I'm going to show you an animation of it as well. Just let it play.
Hello, this is the practical work of the subject pneumatics. My colleague did this scheme on the computer on the program called Fluid Sim Pneumatics. I'm going to show you how it's done it in real life. This down here is the compressor. This is the air unit that has a pressure meter, a filter, and a lubricator. I'm gonna connect this scheme and show you how it works. So first we have to connect all the ones. Like we have these components that can easily be put down with this push button. So these two are the 3-2 push button valves. This right here is an OR valve. This is the double acting cylinder. This is the 5-2 valve. This is the end valve. This here is the is a 3-2 push button valve, and this this is also a 3-2 valve that we use for safety reasons, so the cylinder doesn't automatically go back. And now I'm gonna show you how to connect it. So we connect all the ones. And now that we collected all the ones, we need to connect the rest. So we connect this double acting cylinder on this 5-2 valve, on these two entrances. After that, we have to connect these two push-button valves with our OR cylinder, OR valve. After we've done that, we have to connect these two valves with this end valve. And the last thing we need to do is connect these two valves with the 5-2 valve. And that's the scheme done. Now I'm going to show you how it works. First, we need to let the air out from this air unit. When we do that, either one of these push button valves, when I press this one, the cylinder is closed, is open, and when I click this, the cylinder goes back to its primary position. And when I click this one, it does the same thing, and I still have to do this, and the cylinder is back in its primary station. So now that it's all connected, I'm going to show you how it actually works. First, we have to let the air out from this air unit, and after that, we click either one of these push button valves, and the cylinder opens. When we click this one, it goes back to its primary station, and when we click this one, it does the same thing, and we put it back.